My name is Esteban Torres, and today I will be talking about Svelte. So specifically to the version 3 of Svelte. So first of all, what is Svelte? Is a UA JavaScript framework. Is similar to React and also Vue in that sense, but it has some really nice features and difference that we are going to explore today. And hopefully you like how Svelte manages things. So to begin with, so let's check some stats about Svelte. So first we have it's a relatively new framework, but it's being adopted by some big companies like 1Password, chess.com. So they are using this framework. We can see that also has some like 33 stars in GitHub. That is a lot, and it's also being used by a lot of people. Who is behind this framework is mainly by the open source community, and the first is this person called Rich Harris is the main person behind the framework. So it's not like, like React or Vue that we have, or Angular that we have big companies, but it's also it's really cool that also that it's maintained by the community. So here we can have some statistics also about this. This was taken from the State of JS survey that we have last year. So as we can see, this is the interest for frameworks over time. As we can see, the last year as well is the main framework that is getting a lot of attention. And actually Svelte has been since 2016, but last year was a really big year for Svelte because they launched this new, the version 3 that's really nice. And we are going to focus here mainly in these 3 selling points for Svelte. That the first one is that we can write less code with the framework, really small repositories. Another part is the reactivity, and also that it does not use the virtual DOM. So the reason is that Svelte is a compiler. We're going to take a closer look on that. So the first thing is I have some examples here that we can compare. So this is a really basic application that we have 2 input boxes that we are just binding the value to variables and then displaying that in the template with the result of this operation. So as you can see, we have pretty much like 6 or 7 lines to doing this kind of operation with a framework. And at the first look, you can see that it's really close to vanilla JavaScript, the way we handle things here. So let's compare this kind of application with another frameworks. So this is the React version of that application, and we are using hooks. Is even a little bit less code that regular set state and all of that. And you can see that we have a lot of boilerplate here compared with Svelte that we only have this kind of code. And the same for Vue, even though we can see that this is kind of similar to Vue, we still have some boilerplate here. So that's one of the selling points of the framework. Let's take a look at other feature that's really cool, that is reactivity. So, other frameworks uses tools like libraries like React.js and observables to react to changes. And in Vue, for example, we have something called computed properties. So for Svelte, we are using the JavaScript features for doing this. One feature is called labels statements. So it's more natural in that way, and we can take a look at different kind of reactivity types that we can have with Svelte. So this is a basic local state in some component, as you can see. This will be the equivalent in React. So we have this hook use state that allows us to use declare this these variables that can be changed. So in Svelte, for doing this, we actually only declare the variable, the name of the variable, and we just change the value directly for doing that with the equal operator. So this actually, there's some things that are happening behind the scenes, that we have this invalidate function that is taking the name of the variable as a parameter and the new value. So this is actually what's happening in the compiler, but this is what we write. So it's really intuitive. Another thing that we have is reactivity, what they call reactivity declarations. So this is mainly like computer properties that we can derive from another values. So we have this count value, and what this is declaring a new variable that will be the value will be based on this count value. So this kind of symbol, this API allows us to declare these computer properties, and is reactive. So every time this changes, this will change. See, and another activity feature that we have here is the similar to the previous one, but actually we are not limited to declaring variables. We can write anything between these declarations, and it will in this case, every time this count value changes, it will fire this kind of code. So this is for the reactive features of the language of the framework. Now let's take a look at another characteristic that we have here, is that we are actually not using any kind of virtual DOM for doing this. So some of you might know that some frameworks have this concept of a virtual DOM, that we have this set of nodes that we actually make some difference between the current changes and the changes in the component. So this is great, but actually we have to pay a lot of cost for doing that, because we are doing all of these computations to make the differences. So in this diagram, we can look how this cycle works in this example for comparing React to Svelte. So Svelte, we have the components, then we have the compiler, the Svelte compiler that takes our components. And what happens here is the component, the framework is not present in the application. We transfer our components in native JavaScript, vanilla JavaScript that updates the DOM. Compare this with React. We have the components, we have the JavaScript engine that has to compile these components at runtime. Then we have the virtual DOM nodes and the difference between the DOM changes and the virtual DOM changes. And then we apply the changes to the real DOM. So this is kind of how the process works for this kind of, when we have virtual DOM. And here we are just using vanilla JavaScript to update the DOM. That's really cool, because first we have small bundles, and then we have less time to run the operations in the browsers because of these characteristics. So with that in mind, let's take a look at some practical example of this with a real application. So what I have here, I worked in this application so we can explore the features of Svelte. We have a metronome. Some of you might know how this functions. So basically, it's an application that allows to take a measurement over time. This is used by musicians, so they play in time. So every time we have some measurement here that is how many bits we will have per minute. So in this case, every minute we will have 120 bits. So let's just play it, and there we have 1, 2, 3, 4, 1, 2, 3, 4, and we can change the velocity of this metronome every time we update this range input, and we can also click here to change the value. So this is our application that we will be working today. And let's take a look at the code. So how we structure this. So let me jump to VS Code. And what we have here is, let's first take a look at the folder structure. I use we have some templates for this, for creating a new Svelte application. So I use the Webpack templates. It's kind of similar, you know, that something that we have for React, like create React app, but we have it here for Svelte. And let's first take a look at the dependency. So the first thing that you might notice here is that we actually don't have any direct dependencies. All the dependencies are dev dependencies. This means that nothing of this will run, it will be bundled in the application. This is just for development. And this is the part that I said that Svelte is a compiler. So we take our components and we use the Svelte compiler to transform that in vanilla JavaScript. That's pretty cool. And here we have some, you know, some Webpack configuration. We have the Svelte loader for Webpack and some other things mainly for Webpack. And let's take a look at the Webpack configuration. So the main difference here is that we have this Svelte loader that it take all that Svelte files and could compile that to the correct output. And that's pretty much for it. Let's take a look at what we have in the source folder. So the entry point of this application is this file. So let's take a look at here. So here we are declaring our application we are importing the component, and we are attaching the component to the body HTML element of the page. So that's pretty much it for this entry. We can have more things here, but for this example is really simple in that we have also this public folder where we have our index HTML file where everything, we will render our bundle here, and this is where the application will be attached. This is mainly what we have when we build the project. So let's focus on the source of the application. So this is our main application. And for Svelte, we divide the components in three parts. So the first part is the script, where we have all the JavaScript that will be run in the component. Then we have the style, and here we have the HTML. This is plain HTML, so we don't have to declare any special syntax. And as you can see, we use HTML templates. We don't use JSX for declaring components. So let's take a look at what we have here. So we are importing, making some imports of the audio files that we are playing for the metronome. So here's the two audio files. We have two types of songs. The first, a strong one, and the second one is a little bit lower. We have the component, another component that we will be taking a look. And here we are declaring all of our variables. So just look at this, like these are state declarations. So at first it looks that they're just variables, but these are like, you know, we are keeping our state of this application, and we have to use the let keyword because this will be changing. We cannot use const. So we have the BPM. This is the initial value, that how many bits are playing per minute. We have some flag to check if the metronome is playing. We have here how many bits we have for each measurement. You know, 1, 2, 3, 4. 1, 2, 3, 4. And here we are keeping track of in what bit we are in. So this will be changing depending of in which bit we are. Here we have the minimum amount of BPM that this application can have, and the max amount. And we are declaring here, creating new objects, new audio objects, so we can play those ones. Here is our timer. So we'll be using set interval to keep the time. And here, this is mainly our main variables. Next, we have some functions. So we can control everything in the component. So in this case, we have this update BPM function that takes the event. So this is basically changing every time we are changing the range for the BPMs, and we are updating this BPM value. So as you can see, this is what Svelte uses for update state. We simply use the equal operator. We don't have to use any, set state function or a special function. We just change the value directly with the equal operator. And here we have another function. This function will be called every time we click the play button. So we have some binding, we have some event listen that we will be looking next. And what this is doing is if it's playing, we're going to stop the metronome. And for doing that, we're first clear the interval, and then we set this playing flag to false, and then reset the beat. And if it's not playing, we are going to start the metronome. And for doing that, we are going to create a new interval. And this is what we'll be doing every time the interval is running. It will actually play the click. And this is the range that this will be. So we are taking the BPM and we're dividing. So basically we're transforming the BPM to milliseconds, because as you know, set interval takes milliseconds as a parameter. And we are setting these flags, this playing flag to true, and we're also receiving the beat. And we're playing the click for the first time because this will be called the next time this runs. So what we have here is a function that is playing the beats. So if it's the first beat, it will play the strong hit. Otherwise, it will play the soft click. And we are updating the beat based on the module of the beats per measure. And this last function, what it's doing is every time we change the tempo, it will change it will clear the BPM and will create a new interval. So, every time we change, it will clear the before set timeout and will clear a new one. So every time this changes. So that's basically for the JavaScript part. We're not going to look at the style part because I don't think that's the main focus of this. We will be looking at that later. But let's take a look at the HTML here. So here we are just binding the value. We are just using this syntax. So this means that we can write JavaScript here. So that's why we can, this is changing. So every time we change this value, this will be updated in the DOM. And this is the syntax for doing that. Then we have this component that we've been looking later. And here we have the input. So this is the range input that is controlling the BPM. And here we are just binding the values from the variables. So for binding values, we just use these curly braces. It's similar to how React does that. And this means that we can pass here JavaScript. And let me change this for now. So what we have here is that the value of this metronome is actually be taken from the BPM, and every time the usage changes that we are invoking the update BPM function that is changing the value. And this is the onChange function that we are using every time the user final release the range change, and we are taking that we are handling that. So this is the input. We are, as you can see, we are binding the value and we are reacting to the input of the value to change the state of the component. And then we can take a look at this button that basically what it's doing is just this is how we handle events in Svelte. We only use the on keyword, colon, and the event that we want to listen. So in this case, we are just listening to the click. Every time the users click, we invoke this function. And actually, we can use some modifiers here. So let's say we just want to use this once. So we can say something like this, and this will be only called once. So the next time it doesn't work because I use that modifier. So actually we don't want that in this case. So let's just remove this. And here is just some, what we use for, we are having some JavaScript here, so we can display the play or the stop symbol. Now let's take a look at these components. So these are the components that we are using to changing the values from these buttons. So every time we click here, we are changing the value. And we are passing some properties. So this is very similar to other frameworks. We just pass props, and we use that props in the components. But there are some little bit difference here. So this is we are saying what kind of mode we have for each button. In this case, is the left one is decrease and the right one is increase. But we can also have this special syntax that means mainly what this is doing is doing this. So this is just a shorthand. So it's saying min BPM equals min BPM. And this is exactly the same, but we have some shorthand, so we don't have to write that. And what we have here is that we use the bind keyword for this property. So why we use the bind keyword is because we are changing this value inside the component. That's why we use the bind keyword here. And we will be taking a closer look at this component in a moment, but let's just keep it like that. So a couple of things here that I want to change to make this component better is that we actually don't need to do this value and this handle update BPM function. We can do two-way data binding by just adding this bind keyword in front of here. So what this is doing is every time this value changes, we are reading and updating the BPM value. So we don't need this. And we also don't need this other function here, the function that was updating the BPM manually. So we can get rid of that, and now we just use the bind keyword. And if we save, if we go back here, we can see that this is still working. This is updating as long as we change. So that's nice. So we don't have to write that code. Another thing that I want to change here is that we are repeating this value twice. This is not ideal because we are repeating ourselves. So we can derive this value from another variable. And for doing that, we can use a reactive declaration. So for doing that, we are just going to use this symbol and we are declare a new variable. So for this variable, I'm going to change it BPM interval. And I'm going to say that equals the same thing. It equals the same thing. So the difference here is that okay. So the difference here is that we are using this reactive declaration, and this means that every time the BPM changes, this will be updated. So we can remove this for now. So we don't need it anymore. So let's just use interval. This variable instead. We can use it here, and we can also use it here. So that's nice. That looks more clean, and we can see that this is still working. So every time we update, the interval changes. Okay, so now let's take a look at the other component. So this is the other component that we are using to handle the clicks. If we want to be more precise, we can use these buttons. So are these components. So for declaring properties here is we actually need to use the export keyword. So this is our way to say into Svelte that this variable will be coming from the outside. So if we don't use that, this will not work because this is just local. We actually need to use the export keyword, and it means that it's a property that it will be coming from outside. And this is our way on saying that this is the default value. So if we don't send any, let's say we don't send any mode prop for this one. We didn't send anything. So this will still be working because we have the default value here that in this case is increased. So that's how we declare default properties. And this is the part that I told you before, that we are changing the BPM value here. So we are changing the value from the other component in this directly, and that's why we use the bind keyword. So yeah, that's mainly of what we have now, but let's add some more features here. So the first thing that I want to do here for this application to make it better is that depending on what BPM we have something that's called tempo markings. So this means that we have some names, so we can tell the user in which tempo marking they are, depending on which BPM value they are. So for doing that, I already populate this list that we have all the tempo markings that we'll be using. And here we have some ranges. So if the BPM is from 40 to 60, it means that we are in largo temp. If the BPM is from 60 to 66, it means that we are in larghetto. So that's mainly what we have here, and we have an array. So for doing that, we can actually use another reactive declaration for doing that, because we can react to the BPM changes and display that to the user. So first, I'm going to import that list so we can use it here. This is located in the same directory, and we have it as tempo markings. So we are importing this utility so we can start writing that. And I'm going to change this new variable tempo marking just in singular. And so to know in which tempo marking we are, we can just use this. Because this is an array, we can use the find method, and this JavaScript method will return a callback that we can use with every marking. So we have every marking here, and what we have here is the value that BPM is its measure equals that the marking that mean. It means that is in that range, and also that the BPM is lesser and or equal than the marking punto max. So this is some logic that we can use, so we know our BPM is in the range of the marking. So if we go here, we can see that we have some ranges that we can check, and we are finding that, and we want to display the name of that find. So we have the variable. So now let's just display that to the user. So for doing that, we can use this tag and say tempo. Just display the tempo marking here. So for doing that, we can just use this variable, and there we have it. So that was pretty handy. We just used this reactive declaration, and we can now in which tempo marking. As you can see, we are right now in this moderato marking, and as long as we change it, this also changed because we are updating, and Svelte is reading to that updates. And if it's fast, it's called this. So that's really nice. We have now to the user. Let's add another feature. So another thing that I want here is that I would like to have some visual representation of what is being playing, you know, so we know in which bit we are. So let's just render some dots for doing that, so the user knows in which bit they are. So the first thing that I want to do here is create a new component. This component will be called just that svelte, and we can start by a simple div. So this is basically, it's just a div, and let's add some styles to that div. So one thing that you might be noticing here is that we are using a really high level selector. You might think that this will be applied to all the divs in the component, in the application, but actually we can use this selector because the styles are scoped by default. It means that this style will only be applied to this component. So that's why we can use this selector. And let's just add some properties. So we want to have a width of, let's say, 25 pixels, a height of also 25 pixels. We have to have some border. So let's just add some border here. Let's say 1 pixel solid. And let's use our previous color. So we have some consistency. Let's use this color. And there we have the color, and we want this to be circular. So just border radius, and let's say 50%. So it will make it circular. So we have our dot. So let's just use it in our template, in our previous component, and we are going to import the component. So we just are importing the component dot from that svelte. So we are importing the component, and let's just display it to the user. For now, it's a really simple component. We don't have anything special. And let's use a class for this case, dots, and we are going to use the component. There we have the component. So it's really simple for now, but this is what we want to show to the user. So this, we will have to have for every bit permission, we will have to one dot. In this case, we only have one. We need 4. Why we need 4? Because this is how many bits per measurement we have. So for doing that, I'm going to create an array that have all the bits, and we can also use another reactive declaration for doing that. And let's call this dots equals. And for doing this, I'm going to use some JavaScript new features that we have the spread operator. It means we're going to spread the bits per measure. And we are going to only display the keys of that. So what this is doing is basically creating an array that looks like this. So we have for every bit, we have the index of the value, and we are using some nice JavaScript features for that. So we have the array, but what we want to do now is display for every part of that array displayed a new dot. So we have some logic blocks in Svelte, and we can use the each block. And we can use the each block for arrays or objects. In this case, it's for an array. So we have for each dots as dot, we are going to display this dot feature. And this is the way that how we can declare, how we can display. This is kind of similar of Angular and also Vue. We also have something similar, but this is the way of how we do that in Svelte. And as you can see, we have 4 dots now, but it's looking not good. Let's just add some style here so it looks nicer. So let's just declare this display flex, and let's just send everything to the center. So now it looks better. Okay, that's cool. But we want to show in every click, we want to show in which click the user is. So for doing that, we can use the dot component that we already create and create a new CSS class. So let's say we will have the active class. So if the dot is active, we are going to have a background of the same color. Okay. We have the class, but we also need to declare the variable that the property. So we can use the script tag, and let's say export active equals, and we are going to have a default value of false. Export let active. Okay, we have the variable and we have the class, but now we need to bind this class to the component. And for doing that, we can just use this handy directive that's called class, and we can use colon active. So what does this mean is every time this active variable is true, we are going to apply the active CSS properties. So we could also do something like this, equals active, but we have the shorthand. That's because is the same name of the class, is the same name of the property. So let's just test if this is working. We can say this is true, and we can see that every dot is active, but we want to make this dynamic. So for doing that, we are going to use the active property. And for doing that, we can simply say when this will be active. So this will be active every time the bit is the same as the current index of the dot. So we can say bit. This is the variable that we are keeping track here, the bit. So every time we have a different bit, this will change. So bit equals dot plus 1. Why plus 1? Because this is an index. So as you remember, this is what we have here. So we have indexes, and this is not an index. So we have to make plus 1. Let's see if that works. So we can see that right now it's working. But we have some issue here. So we can see that it's not working for the final dot. So we can do some debugging here. So for doing that, I'm going to use a reactive statement. So this means that I'm not going to declare any variable. I'm just going to write some JavaScript. So let's just log the current bit. So this will be running every time this is updated, and we can see what's happening. So we can see that because the last hit is 0, this is not updating. So we want to write some special logic there. So let's remove this because it's not good to have too many console logs. And we are going to add some logic. So we can say or bit equals 0. but this will be true all the time when this is posted. So what we want to do, check for the last dot of the array, so we can say dots that length -1 equals dot, and there we have it. So now it's working, but this is also being displayed when this is not playing. So we can add another end property here. So we are just going to say when this is playing, and now this should be working. So that's nice. We have some nice features here. Another thing that I want to add here is that this is static. This is just limited to 4 bits per measure, but let's allow the user to change this so they can have whatever they want here. So for doing that, I'm going to use this same input here, and but we are going to bind different values. So the min range will be 1 and the max range will be, let's say 10. And what we want to bind here is not the BPM, is the bits per measurement. We also want to handle the change. So every time we change the bits per measurement, we also react to that. So we have two sliders, and this one will be changing how many bits we have per measurement. So as you can see, we have 1, 2, 1, 2, 1, 2, or we can have 3. 1, 2, 3, 1, 2, 3. Or we can also have 4. And this is changing because this is reactive, and every time we change this value, this dot properties changes. That's nice. And another feature that I wanted to add here is this is a really small application, as you can see. But let's say we have more complex structure, and we want to use, some global store support, so we have everything centralized. So let's see how we can do that with Svelte. So a global store is basically a place where we can keep track of our variables, so we don't have to pass them as properties. We can read the values and update the values directly from the store. So this will be our Redux solution for Svelte. And this is right into the framework. We don't have to use any other library. We are going to create this stores.js file, and here we are going to create the store. So what we want to keep track in the store, I'm going to keep track of the BPM, because we are reading that in these components and also in this component. So it would be nice that we have that in the store. So first, import the tools that we can use to create in these stores. So we have this Svelte/store, and we're going to import this that's called writable. So we have different types of stores. So what we want to use is what Svelte calls a writable. So it means that the store will be changing. So what we are going to do is simply just export the BPM value, and the BPM value will be just a writable. And for here, this function, that what it accepts is the default value. So it will be the same that we have in the other component. So that's it. We will have declared the store, and now let's use it in our application. So for doing that, we need to import the BPM from stores.js. So here we have some issues already, because we already declared the BPM value. So let's now just use the BPM from the store. And we also have another issues here. So that's mainly because this BPM value is not a direct value that we can use. This is actually had some methods that we can interact with. But so for using this value, we can actually just use this kind of syntax that it will allow me to use the BPM value from the store. So what I'm doing here is I'm changing all the BPM references to this $sign symbol. And let's just change that, except this one, of course. And what this is doing, and this one also, we don't want to change. Okay, this was wrong. So we want to that occurrence, not other occurrence. Okay, there we have it. So what we are doing here is basically we are using this value, this $sign value. It tells the compiler. You might think that this is undefined, but actually this is some shorthand that we can use. So this tells the compiler that this value is coming from an store. And let's see what else we have here. So we are binding the value as BPM value. This should be working now. Okay, it works as before. It works as before, and we are not using this value is not using from the components, but by the store. So we are just, let's take advantage of that. So we no longer need to pass this BPM value here. And what we'll be doing is we are going to read the value from the store in these components. So let's do the same thing here. Let's just copy this over here. And let's remove this reference. And we can start using the value from the store. Okay, we changed that, and as we can see, we are changing the value, even though we are using the store. So let's take a closer look, because this might look a little bit confusing at the beginning, but this is what actually is happening. So we can write the same kind of logic here, but we can say that in this way. So we can use directly the value of the store, and here we have some methods. So what is happening behind the scenes is that this $sign is calling the update method that returns the value, and we can say value +1. So this is actually what is happening when we use this $sign symbol. So we are updating the store with a new value, and it's working the same, as you can see, but we have this handy shorthand, so we don't have to write everything of this. And also we also have this subscribe method. So this is the way of how we listen to the changes, but we don't have to do that because we can just use this kind of syntax, and that's I think that's cleaner. And another thing that has Svelte by default, and we can explore a little bit, is that we have animations. So we have, the framework comes with animations, so we don't have to use any third-party component for doing that. So let's take a look at that. So where we want to use the animation, so maybe we want to animate these dots. So every time the dot is active, we display some animation. So let's go back to this component, and we can import the animation from, we have the Svelte. In this case, will be actually a transition. So we have transition and animations, and this will be a scale. So we want to scale every time the component. And how this animation works. So this works by default in the framework every time a component enters the DOM. So for doing, enters or leaves the DOM. So for doing that, we are going to use another Svelte logic block. So we can say if active, and let's just close this, and if it's active, we're going to display this. Otherwise, we can also use this other syntax, that's an else block, and we are just going to display the div like this. So we have the same thing, but we are using now these logic blocks. Actually, we don't need to do this for now because we are not binding, we're directly using the property. And for animating this, because this triggers every time any component, any node enters the DOM, we can use some directives for doing that. We have the transition directive. So we just have to pass the transition that we are going to use. So there we have it. We have the transition scale. So every time you can see that we have some animations, but something is really weird here. So this is because by default, this is triggered every time it enters and leaves the DOM. So what we actually need is only with it when it enters the DOM. So for doing that, we can use this other transition that's called in. So every time this enters the DOM, we are going to trigger this transition. And let's take a look. And there we have it. Now it works as expected. So every time it enters the DOM, we have this really cool animation. Actually, this is very customizable. We can pass some values here and we can use some functions, but let's just change the duration. Let's say duration equals 1000. So this means that you can see that this is lower. We can actually use the value from the BPM because we already know this value. We can use export let BPM interval equals, and we can pass it here, BPM interval. And we can pass the value here directly, BPM. So what this is doing is, depending of the velocity that we are, the animation will be slower or it will be faster, as you can see, because we are passing that value. So that's pretty much it for this practical example. Let's just look at one last thing that we can. So we are leaving this in the air because this timer can go forever. So let's just clean the timer. So for doing that, we can use some lifecycle function that Svelte has. So we can use the on destroy. So this is similar to other frameworks. We can just call this. This will be called every time this component is destroyed. And we can say if timer, let's just clear interval timer. So we are just making sure that this is clear every time we leave the DOM. We are destroying the component, so we don't have anything. We are just cleaning up that. So that's basically for this example. Hope you find it useful. Let's just take a look at another last things for this presentation. So what we have for Svelte is that we have some other tools that we can use along with the framework. We have this Zapper framework that actually is maintained by the same team. And this is the equivalent of, like we have Next.js for React. So we have server-side rendering, and we also have routing. We have some rollup and webpack plugins. We have this tool that allows you to create new components in the website, and we have also some VS Code plugins. So this is mainly what we have in the ecosystem. We also have some community packages, but it's really not that large. So what are the pros, final thoughts of this framework? is that is, as you can see, it's really easy to learn. Why is that? Because the tooling is really close to vanilla JavaScript, so we don't have to learn any crazy thing. If we already know vanilla JavaScript, we're basically done with Svelte. It's really simple. It's really simple. We have small bundles. We also have fast run times, and we also have built-in animations. Some cons is that it's relatively new, and there's not. This can be a con and also a plus, that there's not big tech company behind the framework. And we also have some small ecosystem, as you can see, and there's not official support yet for TypeScript, but it's going to be in the future, as I know. So that's basically the talk for today. Hopefully you find useful and informative. I don't know if you guys have any questions or comments about the framework. Thank you so much for your attention.
Okay, guys. Because of it, we are running out of time, and I think maybe you will have your schedule tight today. So we can send our questions directly to Esteban at our Slack. So you can find him as Esteban.Torres in Slack. So feel free to send your questions about our Launch and Learn today to him, and we are really we thank you because you attending this Launch and Learn. And yeah, that's all. Thank you very much, guys.